In this segment, I'll talk about scribing out the offset for the brass split cotter that I've made that will go inside the wheel head base here, or excuse me, the work head base. So first thing I did, I want to really thank Duncan's Metal Pages. I printed out his whole website and I watched step by step, and as you can see, I calculated what would give me some clearance and then what kind of offset that I needed, and I decided to go ahead and use 805 thousandths offset from the center. So as I've showed before, I used a little dowel rod that I had marked the center point for. I had to shave this thing down with a plane to make it fit inside, because about ½ an inch that way, 3/4 of an inch this way. And then I marked the center with my height gauge, and I set the offset at 805, and I scribed a line across here. I did this last night. Let me show you. So there's the scribed line, and then I used the calipers to mark on from either side to help me get the center of the casting, and then I used the calipers to do an outline of where the brass is, and you can see it pretty clearly, where that little scribed outline, the top semicircle. So it gives me a good way to line up and visualize where the split cotter will go inside. So the next step I want to do is to drill and bore a 9/16 inch hole through this, and then I will use crazy glue. I know it sounds silly, but I've used crazy glue for all the other parts that I've put the split cotter in, and that way it'll be ready. I'll let it dry overnight, and then tomorrow I can bore that out, and I will show you the progress on that. I've just finished drilling out the hole for the split cotter and the workhead base, and I've cleaned both parts up with acetone to get ready for the crazy glue. Wanted to show you, as you can see, if you look inside the hole there, you can see that the hole happily did not go through, even though you can tell it's very close. The bottom of that hole is very close to the top of the core hole. It did not go through, which is a good thing, because I'll be able to crazy glue the brass piece in place, and then I'll press this in all the way, clamp it down, and let it set overnight. And then tomorrow I'll bore the 1-inch hole through the center, and then the next thing after that is to use I'll take the split cotter out, split it, and be able to use that to clamp on a 1-inch bar here, and then I can put the bar in and use that as a mandrel and turn this shoulder down to 1.25 inches outside diameter. That's what it calls for. I want to shout out thanks to my friend Russ. I thought I was going to have to use one of the actual bed bars for that mandrel, but Russ came by today and he brought me a piece of 1-inch stainless that he got from the machine shop that he used to work at, and brought it over to me. He knew that would be handy for me to use as the mandrel, so thanks Russ. And the next step after that, and I'd like to get some feedback from those of you like Maddie that have built the Quorn. There's a couple different variations. The simple way, the original design, is a 5/16 inch bolt that goes through here, and it goes through here in the tilting lever, and it is just a simple clamping thing. But from what I'm reading, apparently that had a tendency to change the adjustment, change the angle when you would tighten down on the bolt. So there's an alternate way that kind of looks like an injector cone or a barbell type design. Very interested to see Duncan used that design from the Duncan metal amps, and apparently it came out satisfactory for him. So I'll read up on that. I'd love to get any feedback if anybody can tell me about that. I'll probably be doing that in the next week or so. So I'd love to have your input. Thanks. A little action shot of boring out the workhead base. As you can see, I'm holding it in the 3-jaw. This Grizzly 12x36 lathe, the 3-jaw chuck is huge, and it fits in there very nicely. I did have to drill out the center. It was an oblong shape. I had to drill it out a little bit round just so I could get the boring bar in there. And the thing's about almost 4.5 inches long, so I needed a long boring bar. And I had to relieve, just like with other parts that I made on the Quorn, I had to grind down some of the shank of this boring wire. Well, still boring the 1-inch hole, or what will eventually be a 1-inch hole in the workhead base. I was getting serious deflection with the other boring bar, and I had to use this smaller boring bar at first, just because the hole was so small. And you can see the area where I reduced the diameter of the shank in order to accommodate the length of the workhead base. But I took some measurements at various levels inside the workhead base itself, and I was getting some serious deflection. In other words, the diameter was narrower at the far end. The tool was deflecting inwards and not cutting uniformly. So I've replaced it with this 3/4 inch boring bar that I got from Grizzly and several years ago, and I know it's strong and will not deflect because this is the exact setup that I used to bore the cylinders on my Allen Mobile locomotive. So a little bit time consuming, but I'm really glad I stopped and checked. I'll bring you back when I have these things bored out to the exact fit to the bed bar. Okay, now the boring is complete. I'm really pleased that I used this giant, thick, heavy-duty boring bar that I got from Grizzly. That's the same one that I used for my locomotive cylinders, and that they were easier because the core hole was already probably an inch, greater than an inch, and the finished diameter, inside diameter of those was like 2 inches. So as I said before, I had to use a smaller boring bar. I drilled out and then used a smaller boring bar to create the space, the initial space to fit this boring bar in. But I've just finished making, it took a lot of passes, but I'm really happy that I took my time. I know it's not the professional way to sneak up on a dimension, but in this case I'm really thrilled. This is the actual rear bar. I took it out of the Quorn to use it as a test to make sure that I had a good fit, and this is exactly what the book is calling for, a close sliding fit. I mean, I don't think there's a half a thou of extra space in there, so this should make a very nice tight, when I use the split collet to split cotter, I always say collet, when I use the split cotter to tighten up on the bar, it should work well. So next steps after this, I'm going to just face off this end and dress it up a little bit, clean the whole thing up, and I can take it out and get ready to mount it on this and use it to turn the spigot on the other side, which I'll do probably tomorrow. Thought I'd capture a couple of seconds of facing off the outside end of the workhead base. Kept the lathe at 70 RPM. This is exactly the speed that I use for boring out the center. I'm just taking off about 10,000 off the outside. Here I've faced the edge, and then I center drilled, and now I'm drilling out holes for 440 screws, 1/4 inch deep. These are on a 1.20-inch bolt circle. The book calls for 1.25. As you can see, I'm just kind of pecking the drill, taking a couple thou at a time. You can hear it bog down. I've been using my tap paste as a lubricant. Right now I'm at 213. A little bit more to go. Probably getting about 3 or 4 thousandths a time. So this is the second of the 3 holes, and then I got to tap them for 440, and I can take this out. See, the Dremel is mounted in the box slide, and I'm using the 3-jaw chuck to do my 3 holes. Alright, about to wrap up for the evening. Very pleased with how things came out. You can see why I modified the bolt pitch circle diameter to 1.2 instead of 1.25, because that bottom hole is very close to the edge. So pretty happy. I've got them all drilled out and tapped 440, and I think we're good to go. So the next time you'll see this, I'll take it out and then I'll use my propane torch to heat that up. It's just crazy glued in, and I've got a 5/16 24 bolt to put in there I can use to tap it and pull it out. To tap it loose, that is, not tap as in thread. So I'm going to leave it be for tonight, and we'll get back at it tomorrow. Alright then, here's the workhead base. I've just taken it out of the 3-jaw chuck, and let's see, you can see the bore. Man, that gives a nice finish. I haven't done anything to it. I haven't used the honing stones or anything, but just using that. The feed is about 4 or 5 thou per inch basically. I mean, per revolution, and I machined it at 70 RPM and just methodically, time after time, going after it with that 3/4 inch boring bar that I showed you. So give a beautiful finish. Let me show you the right there. You can see the brass. Get the focus on there. So that's the split cotter. It's not split yet, but I'm about to. I'll put this in the vise and then heat this up with a propane torch and pull that out, and then I can put it inside the lathe. I'll probably go ahead and use a 5C collet in the collet chuck to split that. I like using that with these kind of things so it doesn't damage the outside. So I'll bring you back and show you that. So I'll basically just split it into 2 pieces and then bore out the front part of it. You can see I've already bored that out 5/16. So any remaining part that's in the front half will just get bored out plain. It won't have threads in it. And then the only threaded portion will be in the back. That's 5/16 24 I used on there. And here's the part with the cotter removed. A trusty Bernzomatic torch. Just heated it up and tapped it out with a punch pin. Didn't take much persuasion to get it out. And it's hard to see the hole in there in this light. Now, I'm not going to pick it up because it's hot, but you can see, there we go. It's going to make a nice engagement in there once I split it out. So I'm going to leave the casting to cool here while I get ready to split the cotter. And before I split the split cotter, I ream out the hole just to be on the safe side for the amount that it's opened up to go to the center portion, which in this case is 675 thou. And then I run the tap through, the 5/16 24 tap through just to clean everything up. Now I've locked it down at 675 thou. I centered the cutoff tool. Got it set on 70 RPM again, which is my favorite speed for cutting. And we'll just cut it off right there in the center. Oh, sorry. And you can see it'll give a nice gap. I think the cutoff blade is just under 100 thou. 330, yeah, 330 seconds, so it's 93 thou. Gives a plenty good cutoff blade. I'm going to stop the cutoff for a second. Put a little bit of I like to use tap paste nowadays for that, for the purpose of lubricating for cutoff. And I'm also going to set, I don't know if you can see this or not, the file, just take to deburr the edge there, because it's going to be impossible to deburr that edge when the cut goes completely through. And this should make a nice clamping action on the front bar. Get this. My object tonight is actually, if you're following along in the sequence, I've been fiddling with this workhead base all week basically. Got it bored out to the final dimension last night. Drilled and tapped the 3 holes on the end. Those should be hopefully all the segments that you've seen leading up to this. And then now I've taken the brass split cotter out that was bored in place, just crazy glued in place, and It holds really well. I mean, I had to heat that thing up with the propane torch for a few minutes so I was able to tap it out. So you'd be surprised how effective Crazy Glue is. And cut through. You can tell we're almost all the way through, taking it really easy, just advancing the cutter a little bit at a time. And you'll see the part that's been bored out, that'll flop to the tray of the lathe in just a second, and I'll be able to clean up the piece that's remaining. I'll run the tap, there we go, clean it up, back out the cutoff wheel, and I'll stop it, and then I'll clean it up, deburr this, and run the tap through it again, just to clean those threads, and I'll bring you back. Here we are machining the outside of the workhead base, turning the spigot, if you will. The new outside diameter would be 1.25 inches. I've got the lathe at 220 RPM. I actually wanted it to go a little bit faster than that, but I got a heck of a vibration. So I'm using the automatic feed, 220 RPM, taking off about 20 thou or so at a time, just not to overdo it. As you can see, I've got it clamped. I've got a bolt in there, 5/16 24 bolt, just like that, and a nut on the back side of it. So it keeps it nice and tight. I'll go back on this again. I've got the outside diameter dialed into 1.25 inches, and one thing I'm doing now is alright, so I've got the spigot, if you will, machined down to 1.25 inches, and it cleaned up really nice. I also cleaned up a little bit of this rim here. Then I loosened it up and I moved it out this way, as you can see, so that I can clean up the very end of it. So that'll be 3/4 inch, and I'll clean it up now. Same RPM. About 11 thou more to go. Just wanted to show that I offset it. The clamping function works really, really well. And after I get done with this, getting it down at 3/4 and all cleaned up, and I'll take a file to it. Make sure I smooth any sharp edges. A little bit more, I'm very close now. Alright, so I'll shut the video off. I'll show you the cleaned up edge. There we go. So I'll take a file to all the sharp edges, being extra careful not to catch the file in any of these protuberances. And the next part will be done on the mill. Okay folks, I wanted to show a couple things here. What I've been doing is following along the Duncan metal amps. So Duncan, if you ever see this, thanks again, man, for putting out this website with awesome, like, step-by-step machining steps. Mine is a little bit out of order from yours just because of the equipment that I'm using, but here is for the rest of you, here is the workhead base so far with the 1-inch bore. And it is a beautiful, perfect fit on the bed bars, and it clamps great. There's a nice inside shot of the, let me see if I can get the light a little bit better for you. Sorry about the noise in the background, folks. That's my neighbors having a party, probably a graduation party or something. It's kind of loud. Anyway, so I got those are the clamps inside the brass split cotter, as you can see. and they worked beautifully, obviously, if I was able to turn the outside diameter of this thing. So I've got this all down just exactly like I want it on this end, this spigot, if you will. 1.25" outside diameter, and that's what I'll use for the rocking lever to fit on. The next steps I have in mind, I'm going to have to play with the setups, and I'll show this. I'm going to do it tomorrow. It's late on Friday night now, so I've gotten done what I wanted to do. But what I kind of have in mind is doing the other steps on the mill, and basically clamping this thing on a bar again, and putting the bar in some V-blocks and clamping those down to the rotary table, because although there's only a few steps left in the machining here, what they involve is drilling, boring out a 5/16 inch center here, and then milling this flat, and once that's bored out, then milling a shoulder, if you will, on this side that a locking bolt can sit on, and then this machining a 2-inch arc from clearing out 2 inches radius from the center of that bolt. So obviously if I start there, I've got everything clamped down and supported perfectly on a rotary table. It'd be pretty easy to machine, offset the machine by 2 inches, and then use a milling cutter to mill out the 2-inch arc for this, and mill this flat to prescribed dimension from the center of the bar to the flat part here. And then finally, and probably the most important reason for wanting to have it on the rotary table, is to engrave division marks. And that's going to be a time-consuming process, the engraving and then stamping of the numbers. So what I may do, I might just go ahead and put all these little snippets together and make this the part 1 of the workhead base video. I'm kind of thinking about that, and then show the rest of the steps as I work through them, boring this hole here, making the notch, machining this out and flat, and then degreeing it and stamping the degree marks. So hope that makes sense to you. This is what I've done. This little sketch here is kind of showing that, and I will keep you posted on the updates. Welcome again to the new subscribers. I appreciate y'all coming along for the journey, and thanks for all the feedback and information that everybody's provided.